Exponential notation, Chapter 1, Lesson 1, Part 1. You should have out your Reteach 1.1 to follow along, and you should also have out your notebook. Feel free to pause or rewind anytime that you see is necessary. First, your vocabulary terms, which should go in your notebook. Exponential notation. That is simply when a number is expressed with a base and an exponent. Example here, we have 10 cubed. The base in our example is the 10. That's the big number, the regular size number. Then an exponent in your example is this 3 here. The exponent tells you how many times you're multiplying the base times itself. Your exponent will always be on the right side of the base and will be small and raised high. Power is just another way to say the exponent. In our example, you could say 10 raised to the third power. Then you have prime factorization, decomposing a number into the product of all of its prime factors. How to convert exponents to multiplication problems. Your exponent, again, tells you how many times you're multiplying a number times itself. So here you have an example of 65 raised to the second power, or this can be said as 65 squared. So because it's raised to the second power, it tells you that you are multiplying 65 times itself 2 times. So this statement is correct because our base is 65, our exponent is 2. Then we have another example here where they give us 6 to the 7th power. They multiplied 7 times itself 1, 2, 3, 4, 5, 6 times. This statement is incorrect because the base is 6, not 7, and the exponent is 7, not 6. So the correct way to write that would have been 6 times itself 7 times. So again, 6, 1, 2, 3, 4, 5, 6, 7 times. Please look at number 18 in your 1.1 packet. Here we show 10, 1, 2, 3, 4 times. 10 multiplied by itself 4 times. And they want to know if 40 to the 4th power is the correct way to write that in exponential notation. This is not correct. It is incorrect. I'm going to abbreviate IC because the base is 10, not 40. So the correct way to write it would be 10, and the exponent would be 4, because again we have it 1, 2, 3, 4 times. Now we're going to look into turning multiplication problems and writing them into exponential form. So the opposite of what we did on the last page. So we're going to look at a repeated multiplication problem, which means the same number is being multiplied over and over again. In this case, you see the number is 101. So that tells us 101 will be your base. To find the exponent, you count how many times it's being multiplied. 1, 2, 3, 4, 5, 6, 7. So that's where this exponent of 7 comes from here. This can be done with any kind of number as long as it is the same number being repeated in multiplication. So in part B, we have negative 8/10 here in decimal form. So that's our base. That's why this is right here, because that's what's being multiplied over and over. And how many times? 1, 2, 3. So the base is negative 8/10 in decimal form with the exponent of 3. Variables can also be included, like it shows in example C. 2/5 P is being multiplied 1, 2, 3, 4 times. So we keep 2/5 P to the 4th power. The reason this is in parentheses here is because they want to emphasize that it's not just P being raised to the 4th power. It's the entire base of 2/5 P. Now, why don't you practice, or we can practice together. We have a base of 6/7. I can see that's what's being repeated. So I'm going to fill that in over here, 6/7. And the exponent, again, I just count how many times it's being repeated. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my exponent. So I simply write it as 6/7. And again, I'm going to put that parentheses around it to show that the whole fraction is being raised to the power of 10, not just the numerator or the denominator. Okay, number 24. Again, I see my base is 36 because that's what's being multiplied. And 1, 2, 3, 4, 5 times 36 to the 5th. Same thing here. I'm going to keep this in parentheses, -6 and 33 100ths in decimal form. And it is multiplied 1, 2, 3 times. Expanding and evaluating exponential expressions. To expand simply means to turn the exponential expression into the multiplication problem, and to evaluate means to solve it. So in this example, 1.6 squared, or 1.6 to the power of 2, I'm writing it as 1.6 times 1.6, and I can use the multiplication to figure out 1.6 times 1.6. I'll multiply through, not adding in my decimal until the end. 6 times 6 is 36. Right, my 6 carry the 3. 6 times 1 is 6, plus 3 is 9. I drop my 0. 1 times 6 is 6. Done with that 3. 1 times 1 is 1. I add those together. 6, 5. Carry my 1. 2. I need to put my decimal back in. There's 1, 2 digits after my decimal in the problem. So I need to put my decimal 1, 2 digits here. So my answer is 2.56. Again, letter B here, -3 to the 3rd power. I multiply it 1, 2, 3 times, and I would get a -27. Not negative, but 4/7 to the 3rd power is 4/7 times itself 3 times. 4 times 4 is 16. 16 times 4 is 64, which is where my numerator comes from. 7 times 7 is 49. 49 times 7 is 343, where my denominator comes from. Let's do the example where we have -1/3 here to the 3rd power. So my multiplication problem, because it's to the 3rd power, I'm going to be multiplying -1/3 3 times. So -1 times -1 would be a +1, times another -1 would be a -1. So my numerator and my answer is -1. And then 3 times 3 is 9, times 3 is 27. So my answer is -1/27. Again, the base is -1/3, is used as a factor 3 times. All right, we have -6 to the 2nd power here. So that means I'm going to multiply it 2 times. -6 times -6 equals +36. Remember, a negative times a negative equals a positive. Then we have 19 times 19 times 19. And you can write it out or use a calculator, but the answer would be 6,859. And that's it for today's lesson.